Chapter 6 by reviewing Section 6.6 on ratio, proportion, and other applied problems. A ratio is a comparison of two quantities. A proportion is an equation that states two ratios are equal. For example, 1 over 2 equals 5 over 10. A over B equals X over Y. A proportion equation: if A over B equals C over D, then A times D, so looking diagonally, is equal to B times C for all real numbers as long as the denominators are not equal to 0. We also call this cross multiplying. Let's go through some examples of where this could be applied. If 3/4 inch on a map represents an actual distance of 20 miles, how long is the distance represented by 4 1/8 inches on the same map? Question mark. So in the initial map measurement, we're saying the ratio is 3/4 of an inch. We have inches in the numerator, is equal to 20 miles. So there's our ratio, 3/4 of an inch over 20 miles. Our second distance that we're saying, what would that be equal to? What if we had 4 1/8 of an inch? So make sure that your inches are both in the same, we're keeping them in the numerator. Would be how many miles? X is our question. So to solve this proportion, we would cross multiply. 3/4 times X equals 20 times 4 1/8, and then solve for X. So we would do 3/4 X. We can simplify before we multiply if we like. Both numbers are divisible by 2. If I divide by 2, I get 5 and, by 4. If I divide by 4, I get 5 and 2. And then canceling any further before multiplying. After multiplying, we get 3x over 4 equals 165 over 2. We can simplify that even further. Factor out of 4. We get 3x equals 330. And then we can divide both sides by 3 to solve for x. So our actual distance would be, if we are measuring 4 1/8 inches on a map, it'd be 110 miles. Here's another example. When we're working with geometry, we're working with similar shapes to triangles. We can write proportions. Both of these triangles are the same shape. They're just different sizes. The length here is 17. The length here we don't know is y. And the diagonal height here is 14, and our diagonal here is 23. Centimeters, inches, we don't know. And then the longest side of our triangle here, which our angle's opening up to, is n and x, and our angles are equal to b. So corresponding sides, we want to look at, the bottom of each, the side of each, and the hypotenuse of each triangle, and write them similar to each other. So if we want to know what is the value of y, find the length of y. Y is the base of triangle B here. So we would put base of A, 17, over base of B, y. As long as we're using the numbers from triangle A and always putting those in the numerator, we can do that. You could also write it in reverse. So maybe you started with y first and you put y over 17. That's okay, as long as you also start with 23 and put that over 14. Either way, you would end up with the same result when you cross multiply and simplify to solve for that variable of y. In this case, y, after cross multiplying and dividing, we get 27 13/14 of an inch. Here's a second example. Terry drove his car to Cleveland while Kathy drove her car to Columbus. Terry drove 360 kilometers while Kathy drove 280 kilometers. We must be in England. Terry drove 20 kilometers per hour faster than Kathy on his trip. What was the average speed in kilometers per hour for each driver? So this one has us do a couple things. First, let's figure out what do we need to know to solve this problem, right? We need to know average speed in kilometers per hour. So that's called a rate, right? What's our rate? Distance is equal to rate times time. So we need to know that equation here, this little formula. So we can let R be the rate of Kathy's car, and since Terry is driving 20 kilometers faster, R plus 20 would equal the rate of Terry's car. For the time, T, for each driver, it was the same. It was the same. We can also make a table to help us see the relationships here. So here's our distances, our rates, and our time. So let's write an equation, a proportion to solve for our rate. So the first person, Terry, drove a total of 360 miles or kilometers, while Kathy drove 280 kilometers. So in the numerator, we want to make sure that the label that we're using is the same. Distance, distance. Okay. Distance of person 1, distance of person 2. Rate of person 1, rate of person 2. Then we can cross multiply and solve. So here we've cross multiplied, simplified, distributed parentheses, divided to solve for our variable R, and we know that Kathy's rate would be 70 kilometers per hour. And why is that? Well, we solved for R. R equals 70. This is Kathy on the right. Terry was on the left, and his is R plus 20. So 70 plus 20 would mean Terry drove 90 kilometers per hour. Let's look at a different example. At KeyBank, it takes a computer 4 hours to process and print monthly statements. When a second computer is used and the two computers work together, the statements can be printed in 3 hours. How long would it take the second computer by itself to process and print the monthly statements? If it takes the first computer 4 hours to print the statements, then in 1 hour, the computer would finish 1/4 of the job. If it takes both computers working together 3 hours to print the statements, then in 1 hour, both computers would finish 1/3 of the job. So let's let X equal the number of hours it takes the second computer to finish the job. In 1 hour, the second computer would finish 1/X of the job. So let's write an equation. Amount of work done by first computer was 1/4, plus the amount of work done by second computer is 1/X, equals the whole task completed, which is 1/3. Let's solve and state an answer. So if we are looking to solve this, we want to figure out what's the least common denominator. Well, that would be 4 times x times 3, which would be the same as 12x. 4 times 3 is 12. So we multiply each term by 12x, which gives us 3x plus 12 equals 4x. Solve for x, so subtract 3x. We're left with x equals 12. So when working alone, it would take the second computer 12 hours to print the statements.